again, you guys have a lot of experience. You've seen a lot of models in production or some that didn't make it to production. Where do you see most machine learning projects fail? And I say projects and not models, because we're more interested, again, how do we bring value to the business or to the team? And on that note, what would you tell a junior data scientist to be careful about? What was kind of like your number one tip for someone coming into the industry?
Maybe I can go on this one first. Well, in terms of failures, I would say a couple situations that usually arise, at least in my experiences, are when you don't know beforehand really well what you're optimizing for. And when you try to deploy a model, the model is not really doing what you expect them to do. And when I say what you're optimizing for, I don't really mean which loss you're optimizing for, but actually what's the final goal. And one example I can give is that, for recommender systems, if you have your model that has like a higher mean reciprocal rank or whatever metric that you care about, but when you put it in the hands of the users, what you're actually trying to optimize for is maybe the click-through rate, or maybe even a more downstream metric, like how many items did they end up buying, or did they end up watching, depending on whatever you're suggesting, right? And so there's not always a one-on-one kind of relationship between the performance that you see offline and the performance that you see online. And sometimes even like big gaps offline do not translate in huge gaps online. And so that's, one of the aspects that make it so that even things that look promising at the beginning do not end up deployed in production. And the other aspect that I want to stress is the fact that when you have a model and you put it into production, there's, well, depending on the tasks, obviously, but in many cases, there's going to be a kind of distribution shift with respect to the data that you trained it on and the data that you end up using it for producing predictions. And the more time it passes, the more distribution shift there is. And so many projects are kind of, if they don't do a good job at monitoring and iteratively improving the models and readapting them and making sure that they are as aligned as possible with what's current in the distribution of data, that's another failure case that I've seen, like model degrading performance a lot over time.
Yeah, I think Piero brings up very good points. The first, both of them actually, and the first one where in a big system, your model is not the only one that's there in the system, right? So as Piero said, having big offline gains doesn't always translate to online gains. And one of the major reasons is you might not be providing any orthogonal signal to this new fancy model that you're training. So it always makes sense to kind of understand what your final goal is. And typically, as Piero said, the final goal is not just this one single objective that you drive CTR or you drive, how much a person buys, but there are auxiliary goals as well, right? You don't send out clickbait articles. And, when a person buys something, you also want to make sure they don't return it. So you have to make sure of those things as well, right? So you have to, and you can't train a model keeping all these goals in mind at the same time. You have to do A/B testing. So making sure that you do A/B testing, you look at that data when it comes back. Yeah, it makes a lot of difference. And maybe not having an eye out to looking at those data and being willing to fail the first few times. You have to be willing to, you deploy a new model, it probably won't do better than the existing one. So you have to be willing to, stick your neck and do it a few more times.
Totally agree.
Yeah, I think one thing that it's kind of a rookie error, a rookie mistake, in acquiring what you were saying earlier, is that if you don't take into account the production constraints right from the beginning, you can end up with an overcomplicated model that will never be pushed into production. We all have this famous, I don't know if it's a myth or a legend or anything, of this Netflix Kaggle, where the winners had this overly engineered great model that was like had a super high accuracy, but it took like 24 hours to run. So like they were never going to push that like for real time production. And so if you don't take like these constraints like right from the beginning, like you can steer your wheel to another direction that is not relevant like at the end.
Go ahead.
Sorry. Another point like that I fall into like when I was beginning is like being stuck in like wishful thinking. So like kind of looking at your results and not seeing what they say, but interpreting them like the results as the way you want, and like kind of like, oh, this thing is magic. And it can be super dangerous, like especially at the beginning, not seeing the results for what they are. And like, yeah, being stuck in wishful thinking can be dangerous, especially like when you hit the deadline. I'm super biased by like conferences cycles. So yeah, be careful about that.
I can totally agree. Like you have to be the harshest judge of the output of your own model, right? Like, otherwise you get stuck into thinking that it's doing things that it's not. Right?
Yeah.
Another point that Piero brought up, right? The distributional shift. As you introduce a new model, that introduces a distributional shift in your data. I think that's very interesting. And having continuous retraining pipelines where data keeps flowing in and you keep on retraining your model. It's easier said than done though, right? Because you have to know how many steps you want to fine tune. How do you want to set the learning rate, right? If there are new objects coming in, especially if they're sparse objects, right? How do you accommodate them without increasing the size of your model? So there's a lot of systems work that goes in the background if you have to put something in production.